Hey, what's up, guys? This is Chung here. So let's continue our QuadTree implementations here. So in the previous video, we implement a QuadTree data structure where we can visualize the data, the QuadTree, by generating this kind of like 2D grid here. And as you guys can see, so for this one, we have 1000 random points on this 2D grid, and then we we use this visualization to draw this kind of grid grid to represent like the structure of the quad tree. So so in this video, let's try to see how can we utilize this quad tree to help us do the range search, the the range search. So for example, we have this one, and let's say let's start it with a simpler one. Let's just since we have everything as a rectangle, let's just use a rectangle. For example, if I draw these rectangles, how can I know? How can I get all the points that within this rectangle, right? So to do that, what we're gonna do, so we're gonna like we're still going to start from at the beginning, at the center, at the root of the quad tree, and then we'll just try try to write intersects helper functions within each of the rectangle. As long as we have an intersect with this range here, right? Basically, we have this range. We have the range is like a rectangle, right? And then we will what? We will like try to go. We'll try to go to that rectangles or the quad tree, and then we'll try to find the points within that range. If there's no intersect with that quad tree or the rectangle, we simply ignore that parts. Okay, so that's the basic idea. Okay, so let's try to implement that. So to implement that, and what we need to do is we need to write helper functions in the rectangle first, right? So this rectangle helper functions will just tell us if there's an intersect uh, with a given range, right? So we're gonna have like, sorry, we have like intersects, right? So we have a self, and then we have a range. So keep in mind this range is also a rectangle, okay? And okay, so for that, if how can I know if there's an intersect, that's kind of given like two rectangles, right? So I think the easiest way is that we just we just try all four cases. So we have this is the west, this is the north, right? North, east, and south. This is also the north, west, south, and the east. Okay. And as you guys can see here, if given this kind of like the 2D grid here, right? We have 0, 0 here. That's how we define it, right? I mean, if the S is if the n is greater than S or the S is greater than n, then we know, okay, so they're not intersects, right? Same thing for the west and the east, and also the another case is like this, right? If the another one is right here, another rectangle, S and E. If the S is greater than N, and if the W is greater than E, then basically there are four cases, right? That can tell us they are not intersects. So and all the other cases, it means that there is an intersect. So we can simply just list all that four cases here, return not. As long as it's not one of those four cases, then we know it's true. So the four cases is like if the west is greater, the range west, right? So this is the current one. This is the range. This is the range. This is the range. If the range west is greater than the south dot east, right? Or the range dot east is smaller than the south dot west, okay, or the range dot north is greater than the south dot south, and the last one is the range dot south, right? It's smaller than the south dot north, okay. As long as there's not one of those four cases, then we know there is an intersect. Okay, cool. So that's that. And now we can implement the main structure, with the inside this quad tree, because that's only to check the rectangle with one rectangle with another one. So in order to recursively check that, we have to write another functions inside this quad tree class, where let's try to write a new functions here. Query range, right? I call it query range and then the self, of course, and then I pass in a range. So, for query range here, I'm going to create like a find point list where it will return all the points, right? All the points that the current quad tree, have for this range, because we'll be using this returned find points to highlight those those find points. All right, so first thing first, if not self dot boundaries, right, dot intersects with the range, right? If the current quad tree does not intersect with this range, there's no need to keep going. We can simply return the we can simply return an empty list here, right? Else, what is else? So else is that for point, else there's intersect. So we just need to know that, if the point for each point in the self dot points, right? We check if the points within this current class belongs to the range, right? And the way we're checking is if the range dot contains points. Since for each rectangles we have this kind of helper functions, right? Can tell us if a point is within this range and within this rectangle, and the range is it happens to be a rectangle. That's why we can use the range dot contains point to check the point, right? So if the point is in the range, then we append the points, right? Append the points to this find the points. So but this is only to check the self points, right? So, and we also need to recursively go into each of the subtree. So first, let's check if the divided is true, right? If the divided is true, and then we do what? We simply do a find dot points dot extend, right? So we extend everything that's south dot northwest dot query range. And as you guys can see, so here is another like recursive call, right? So for the northwest subtree, we also call his query range, and we pass in this range inside that, and then inside the query range it will also check if there's an intersect with this range. If there's not, then we simply return an empty list. If there is, then we check the points inside this northwest subtree, right? And then we continue. That's why I'm going to just copy and paste 4 lines here, because this is the northwest, northeast, southwest, and southeast, right? And actually, as you guys can see here, so this is where the quad tree will help us to improve the performance of a searching. Because first, if there's no intersects with the current quad tree, right, we will simply ignore it, and then we only will do this for loop here when there is an intersect. And since we have a capacity for each of the quad tree, So this self dot point will not be super big. So in this case, the biggest length of this one is just a 4 here. That's why we can just limit the for loop a lot, right? By setting up the capacity for each of the, the quad tree. So and then in the end here, we just simply return the found dot points, right? Okay, so let's see, is there anything else left here? And yeah, and I believe that's it, right? Okay, so now let's try to highlight those find points, right? How can I do it? So we have here, let me see where I can do that, you know. Yeah, here. So let's try to generate the range. Okay. Mm. So to generate the range, you know, I'm going to generate the center point x to the np dot random dot rand, right? And then I'm going to the width, right? To the width, and then center y equals to this dot height. So this will give me a random center point for this for the range we're we're using here, and then for the range width, right? I'm also going to do a random generation here because the range of the width will also need to be a random number here. So we have a random number here, and then which times what times the minimum hour. So here is a little thing. So you guys can skip this part. So this is my way of generating the range width and range height. So this is going to be width minus dot center, right? Because you know it does because here if the point is somewhere here, right? So the width has to be the smaller of these two parts because we don't want the range rectangle out of the the domain here, right? The big rectangle here. That's why I'm doing a minimum of that, you know, of x, sorry. So same thing for the range height, right? Range height, range height of this thing now it should be y, and then the height should be the height minus this y, right? So now I have a random center point, and for the random center point, I also have like a random width and height. So now I can just create the range here, right? So the range is the rectangle, right? Rectangle with the point. So it's the point of the center x dot center y, right? And then we have a range width, and then the range height. Uh, yeah. All right. So the next thing is to define like find points so that we can get all the points within this range here, right? Mm, then we have a find points equals to the what? The quad tree dot query dot query. I think it's a query range, right? And then we just pass in this range here. Yeah. So And let's see what else. Yeah, so after getting all the find points, let's just try to highlight those things. So the way we're highlighting is like this. I'll just copy and paste the code here. Basically, we do another scatter by the point we have find, and then we just do a color by color with a red color. All right, and then let's do a range join, right? So let's draw the range first, DRAW, and with, a, with this AX, and then the color is red, right? Let's highlight it as red, and the line weight, I'll just give it a 2 here. All right, cool. So let's try to run the code here and see if it works. So exciting, the moment for truth. Start debugging. All right, cool. So it seems like it's working. Since we are like randomly picking the location and the size of the rectangles, so the so we have this number of find points here. Actually, let's try to print out the point we have find so far. Oh, here is it? Did we find it? Let's see. Points. So total points. Let's try to print a find points here. Let's try to print like how many points we have within that range, right? Print dot points in range, right? Is the length of the find points, right? Okay, so let's try to run this code one more time. Let's see what we got here this time. All right. Hmm. Okay, so it seems like this one we have different like range here, right? So and as you guys can see, out of 1,000, there are 202 points within this range. And as you guys can see here, all the points are highlighted here. Okay, cool. Just let's try another one. Just for fun. Bah, bad luck for us. Now this time we have a very small range, so that's why there are only 5 points in this range here. Cool. So that's how we find the range here. And so what's next? So the next thing is that, if you guys ever use the Yelp or the Uber or Lyft, usually what we are asking the Yelp to help to find is not we're not using a rectangle. Instead, we're using a radius, right? So a radius is like a circle, right? Basically, we're standing right in the middle, and we're asking the Yelp to give us all the points within this radius. So that this is the radius. But here we're using the rectangles. So now the next question is how can we modify our search our query function so that we can the uh, only queries the point within this circle, not the rectangle. So the way we're doing it is that still we're going to use the rectangle class, but instead we're going to get from the circle we can get the square, right? Because with this radius, basically, the width and height are the same, right? And with this radius and the center point, we can create a square. It actually is another special form of the rectangle, right? So and we pass this square as a range into the query functions, into a new query functions. But instead of using the the contained points of the rectangle, we need to calculate basically. So for this time, we also need to pass in the center point because now the way we're finding it, we're finding we're going to calculate each point the distance between between each point and the center points. And as long as the distance is smaller or equal than this radius, then we know okay, that point is within this circle here. So that's why this one is okay. This one is also okay, but this one is not, right? Because the distance between this point and the center is greater than r. So that's how we will be doing. Okay, so let's do it, right? Okay, so to do that, I'm going to create a new query functions here. So it's not query range anymore. It's called and query radius. How about that? Radius. And for the query radius, like I said, we need a few more parameters. So the first one is still the range. Second one is the center, right? And yeah, do we need a radius? No, we don't need a radius because the range dot width where the height is the radius. Cool. So and similar like this one, right? Similar like I'll just copy and paste this one here. Actually, similar. The structure is pretty much the same. We're still going to check the intersects, but here, instead of using the range dot contains point here, we are going to add one more thing here. We're going to like the point dot distance to center, and then we pass in this center. Okay, is equal or smaller than the range dot width. Okay, right. Then we append these things, and then here we are still going to recursively call this radius for all those kind of four sub QuadTrees, and then we'll be passing the centers to each one of them. Okay, here, and here. Okay, and then in the end, we also return the find points here, right? So that's that. And okay, so now let's implement this one here. So this one is pretty straightforward. We just do a square footage with the x difference and the y difference, right? So oh sorry, it's not in the rectangles, it's in the point class, right? Sorry. So in the point class we're gonna define like distance. Oh, I like this IntelliSense here. So self dot center, right? We're going to return the math of dot square root of the center dot x minus self dot x and do a to the power of 2 plus the center of dot y minus self dot y, right? And then also do a power of 2. So I think to use the math square footage, we have to import the math class, the library here. Cool. So I think that's all we need to do for those two classes, and the rest will be in this test class here. So let's try to run so instead of let's see the radius. So where's the radius? Let's see. Okay. So now I'm not going, so I'm going to keep this here, but I'm not going to use this range here. Instead of using the range, I'll be using a different functions here. So now the radius, so let's define a radius, right? So the radius is what? The radius is basically the minimum of the range dot width and the range dot width and the range of height, right? Since we only need one, that's why we need to get the minimum between those two here, right? So now the find points will be equal to the QuadTree dot query radius, okay? And then we'll be passing this range, the range. Oh, sorry. So we haven't created this range first. So the range will be this one, right? So same thing here, but instead of using a range width, I'll be just using two radius here. Okay. So now we have a range, and then we have the range, and then we have the center point, right? We also need to pass in the center points because that's how we're going to calculate I mean the distance. Okay, cool. I think that's pretty much it is. All right, let's try to run the code. Let's try to test it again. Run. Hmm. Rate. Oh, I think radius. All right, there's a typo here. Okay. Ah, bad luck. This time the range is too small. Let's try to run it again. Let's see if we can find a bigger one here, bigger circle here. Okay, so this time it's better, but it actually it's kind of hard, right, to see the difference between like the rectangles and the radius. So to fix that, let's try to fix the center point and the radius. So let's try to hard code it, the center point. I'm just going to use the center points. So which will be the what? The half of the total width is 300, right? And then the center y is the 200. Okay, and for the radius, I'll just use like hard-coded values here, and gonna be a radius equals to what? Let's try 150. I think this should be big enough. All right, so now we have a fixed range here. So let's try it one more time. All right, cool. So is it why it's not okay? 300, 200, 150. Okay, N never mind. I thought that this is gonna be somewhere here, but it's irrelevant. But this time, as you guys can see here, now we have there's only a highlighted there are only this kind of basically there is a circle here, right? Circle here, and as you guys can see here, only the points that within this circle are highlighted, and the points are on this outside of circles they are not highlighted, which means that they're not being queried. Okay, cool. Yeah, I think that should be everything for the class for this QuadTree class. I think that's basically all the functionalities we will need to do the query. So maybe a few more things that how can we so now we're only adding the points. okay, right? I mean, we're only trying to split the quad tree into four subtrees. How about removing the points, right? Like in Yelp, let's say if some of the business or restaurant they're permanently closed, and we need to remove that points from our structure. And how can we shrink that? How can we do it, right? I mean, I think I'm not going to implement that here, but I'll just throw some idea here, you know. So the way is that we still, right, we need to find the we'll use this QuadTree query and we'll find that point. Basically, we'll pass in that point, and then we'll try to find the QuadTree that holds that point, and then we'll simply remove the that point from the self dot points list. And whenever the point is has reached to 0, we're supposed to remove this quad tree, right? But it's better to not do it immediately, because you know, if let's say if there are like a huge request coming in that will remove a lot of points, and then we'll like basically we'll have a lot of threads or a lot of process that will try to remove update the quad tree at the same time, which will be a burden, right, to the system. So a better way of doing it is that it's called a lazy collection. You know, instead of doing it immediately, we just remove the point. Whenever it reaches 0, so we just leave it there and we don't do anything. But there's like gonna be a background process that will periodically scan the entire quad tree. And whenever he sees like a quad tree that has 0 self points, right, it will just uh, it'll just basically remove that remove this like the the reference from this quadtree. And while doing that, it will also repeatedly call another remove function inside of this like the inside of the subtree, because you know mm, because the actually the total points, right, it's not just one point. Actually it's the total points of all the subtree, all the subtrees of this this points plus all the points within his subtree, the northwest, northeast, southwest, and southeast. If the total point is 0, then we know, okay, we can safely remove this quad tree from the entire structure. And after removing this one, we also need to recursively call the remove functions for each of the subtree, because we know we those trees must have already also be an empty tree. So we also need to recursively remove everything. Yep, I think that's pretty much it is, you know. Okay, I don't have anything else I want to talk about. That's pretty much the quad tree implementation and visualizations here. And yeah, I think it's a pretty fun coding challenge here, you know. Let me know what you guys think, and I'd like to hear some feedbacks from you guys. If you guys kind of enjoy this kind of like coding challenge videos, other than just solving the algorithm lead code problems, you know. And cool, yeah, I'll just stop here. Thank you so much for watching this kind of videos, and stay tuned. I'll see you guys soon. Bye bye.